Good morning, mathematicians. Today's also not going to be a very long office hour. I will be interviewing Professor Kontorovich in less than an hour, so I gotta go get ready for that. But before that happens, I'm going to be doing a constructivist questionnaire that a follower emailed me a while ago, and I'd meant to do it earlier. So, Nerd Coke, for those of you who are familiar with the name that pops up frequently in chat, Nerd Coke. Yeah. So that's what we're gonna do first, and then who knows? Maybe there'll be time to yap about other nonsense. Yes, most indeed. Most indeedy. Okay. Let's look at the questionnaire. Questionnaire has its goal to investigate the opinions of the mathematical community on intuitionism. To this end, it presents 10 slightly provocative questions and collects answers to these questions from as many people as possible. Each question should be answered yes or no or mu. Or it depends or maybe. Okay. I mean, this is office hours, so I'm gonna yap. I'll try to first give a condensed version and then I'll yap. Try to have as little moo as possible. I wonder, is moo? What is moo? Is there another meaning to? Is there another? No, that's not what I wanted. Although I do go to MuScore often. Just the term mu. Well, I'm just wondering because it also appears in Douglas Hofstadter's his MIU puzzle. Whoa! Look at the stock changing in real time. Time to buy. Time to buy. You think I should go all in? Well, maybe not. Oh yeah, no, that was a bad idea. Okay. Yo, where is everyone? How's chat? How's chat not bumping already? Where are y'all? Maybe I need to restart chat. No, you guys just really aren't here today. Damn. Damn. Oh, never mind. Russ is here. Hey, Russ. How's you did all your applications? How's the application grind? Everything's applied for? Okay, let's get to this questionnaire. Do you agree that it is possible to define a total function from the reals to the reals which is not continuous? Yes, I agree it is possible. Yeah. Nothing more needs to be said. Nice. Well, good luck. Good luck. Do you agree that the intermediate value theorem does not hold the way that it is normally stated? Huh. I'm gonna have to. Well, I don't know. It is a loaded question. Yeah, the point is they're all supposed to be loaded questions. And actually, I kind of want to change my answer to one to be it depends, right? Because it all depends. It depends. It depends if I feel like using the law of excluded middle that day or not. Same thing with question 2. Question 3 is interesting. Do I agree that there are only 3 infinite cardinalities? That is interesting because I'm not aware of any constructivist claim that there's only 3 infinite cardinalities. And what are the 3? What are the 3? Countable? The continuum. Oh, sorry, I disconnected for a second. Uh, yeah, pizza's 20 euros. That's a lot. That's a lot in Canadian. That's like $100 Canadian. Not really, but um, uh, yeah. You know what? Just make your own pizza at home though. I got. When I went to Italy a couple years ago, I was inspired to make better pizza at home, and then I did, and now I do generally prefer my pizza. Although lately I have been there's a pizza shop literally outside the front door of my apartment, and so I've been inclined to get pizza from them. But it's good in a different way. It's good in an American sense of pizza, and I feel like there's just something. It's good because of the egregious amount of cheese and vegetables he puts on it. But that's different from the way Italian pizza is good. It's so simple, but the beauty's in the dough. Yeah. Um, could I help you with a question you've been working on? G is a group, H is a subset of G, then H is a subgroup if and only if H is non-empty, and that. Aha. This is the so-called one-step subgroup test. So-called one-step subgroup test. Well, what do we need to show? I didn't get my drawing pad. Give me 1 second. The Rothney Observatory? Which one's that? Is that the observatory just outside of Calgary? Yes, I've been once. If it is, then who are you and how do you know that? If it's not, then I don't know. I don't know what observatory you're talking about. You'll drain. You mean drown? Drown your pizza with garlic? Good. That's important. Oh, it is the one in Calgary. Yeah, I went once. There was, I guess the disconnecting. OBS says I keep cutting in and out. So hopefully it's not too crazy for you guys. But, so what do we need to do to prove that, H is a subgroup, right? I mean, what does it mean? H has to be a group, and it has to be closed under the multiplication of G, right? That's what it. I cut out for 30 seconds. Jesus Christ, really? 30 seconds? I don't know how much you guys missed then. Anyways, so H needs to contain the identity. So, for example, we have the fact that for all A and B in H, we have that AB inverse is in H, right? So that means that and H is non-empty. So I know I can choose some A in H, but then using this property and taking B to be A, I know that A inverse is in H, which means that the identity is in there. And then what's the next thing that I need to show? Well, I mean, the operation's already associative because it's associative in G. So the only other thing you need to show is that it's preserved under multiplication. But of course it is, right? Because hang on a second. How do we do this step? First I need to prove that it's closed under H contains AB inverse. Sorry guys, I don't know why I keep disconnecting. I don't know what's going on today. Yeah. But so I paused for it keeps disconnecting. I don't know. I don't know what's going on. Finally, to see that it is closed under um, products, AB is in here, then we just argued that B inverse is in here. So now we take in this formula here B to be B inverse, right? Because it tells us that H has to contain A times B inverse inverse, which is of course A times B. And there we have we conclude that H is a subgroup. Wow, I can watch this infinite chain of myself pausing and unpausing. This is crazy. Maybe don't talk about groups. Yeah, okay. I should restart stream. Well, I'm just gonna end stream soon, I think. Unless it's the internet. You really love that eye scratch. Okay, well, glad I'm doing something right as a streamer. Do I have any tips for PhD interviews? I've never done a PhD interview. I've never done a PhD interview. In fact, I don't even know that many people that did an interview for a PhD. Most people, you just get accepted or you don't. So, yeah, unfortunately, I have no idea. I mean, if it's anything like my postdoc interview, he just wanted me to give a little presentation on my research, and then just wanted to chat a bit, so it's not like, I don't know, maybe PhD is different, but the interview I had was not like high pressure, you need to perform and demonstrate how much you know. So I don't know what the attitude of this interview is, because you also want to get along with with the person. So it literally could just be an interview about like seeing if they're chill. I don't know. 4, what are you saying about 4? Do you agree that the continuum hypothesis is a meaningful statement that has a definite truth value? No, what are you talking about? It is not lem with extra steps, not even close. Yeah. But do I agree? That's the question. Is a meaningful statement that has a definite truth value? No, I don't agree. Hang on a second. I don't agree. Do I have any favorite Erdish papers? No. I have an Erdish number 2. I don't think I've read a single paper of Erdish, though. I don't think I've actually read a single paper of Erdish. I've read some results of his, but I don't know if I've actually ever cracked open an Erdish paper. Yeah. Well, it's kind of both, Locke. It's kind of both. And yeah, I mean, opinions about constructivism is all philosophy, anyways. Do you agree that the axiom which states the existence of an inaccessible cardinal is a meaningful statement that has a definite truth value? It'd be so funny for me to say yes to this one. No, I mean, of course I don't. Do I agree that for any mathematical question, it is easy to build a machine with 2 lights? Yes and no. where the light marked yes will be on if it's true, and the light marked no will be on if it's false. We specify that machine is not allowed to have both lights on, else the question would be trivial. No. Do you agree that for any two statements, the first... this questionnaire... Here's the thing that's so stupid about this questionnaire, right? This questionnaire is so stupid because, like, even if you were a devout constructivist, surely you would acknowledge that your non-constructivist colleagues are doing math are still asking. Oh, dead again. So yeah, you guys were wrong. It wasn't because of the group theory. Although stream did stop dying as much when I moved away from group theory. Interview Luna on why there is so much weirdness on R, whereas there is only one N we really care about. Is there really one N that we care about? Because actually, yeah, so Luna mentioned this in Discord. We were chatting afterwards, and they said that the natural numbers that you have depends on your model of set theory. But is it true, actually? I meant to ask this. Is it true that we construct N as the intersection of all inductive sets? Is that right? That seems right. But I thought... I guess I thought there was some other way that we build it. I'm thinking about from Herbacic and Yek. Some sort of recursive procedure after we have the axiom of infinity. But perhaps I'm just thinking about how we define addition and prove properties about it. Okay, axiom of infinity. Yes, okay. It is also defined here as the intersection. I see. Yeah. Very interesting. What's an inductive set? It is a set such that if X is in S, then the successor of X, which is X union the set containing X, also belongs to S. That's what it means to be inductive. And we do it this way because in set theory, we define 0 to be the empty set, and we define 1 to be the successor of the empty set, which is the set containing the empty set. And we define 2 to be the successor of 1, and so on and so forth. So, and the axiom of infinity posits that an inductive set exists. To weed out all the non-standard models? Well, no, I don't think that... No, because this is happening within a model of set theory, right? So if you have weirder, like, it depends on your set theory, because the set theory that you're working in, that determines how many, like, inductive, or what kind of inductive sets can even exist, right? So... yeah, it doesn't, yeah, that's my understanding anyways. The weirdness of R comes from power set axiom. Yeah, you know what? I feel like not enough people talk about rejecting the power set axiom. I feel like more people should, we talk about abandoning the axiom of infinity. We talk about abandoning law of excluded middle. Not enough people talk about abandoning power set. Set theorists are always talking about how power set is worse than choice. Oh, are they really? Wow, this just shows more of my ignorance of set theory. I would love to hear more about why set theorists say power set is worse than choice. Really, it's the most commonly taken out axiom. I don't know. Really? No. Really? Okay, maybe in the set theory Discord, I'll have to go ask people to dunk on power set. I'd love to hear more of the set theorists dunking on power set. In set theory research, okay. I'm still surprised by that. Do you agree that any two statements, the first implies the second, or the second implies the first? Wait, is this when? Let's see. Well, if they were both true, then that would happen. If one was true and one was false, then yes, one of the... And if they're both false, so... But somehow I'm using lem in there, right? So... It depends. Yeah, 100% I agree to 8. Yes, 100% I agree to 8. I agree. A constructive proof of a theorem gives more insight than a classical proof. Anyone who disagrees with me is bad and wrong. How would we show that n is closed under addition using the successor function? Well, how you show that is you write like tens of pages building up the theory of recursion, as in this textbook here. Yeah, where is it? Where's the definition? Where does it start? Yeah, I remember going through this being a bit of a slog, actually proving it. Actually, maybe it's not tens of pages, but it's not so straightforward. I mean, yeah, there's a bunch of work here. I mean, so here on page 41, you insert the axiom of infinity to talk about to define the natural numbers. You prove the principle of induction. Then over on page 46, you start constructing the recursion theorem. This allows you to basically do iterative processes like addition and multiplication. And so what did I say? That was page 46. And yeah, it's a bit of a slog of proving a bunch of stuff until... Yeah, I mean, you need to first set up a bunch of stuff on recursion, and then over on page 52, 53 is where you actually start defining arithmetic and proving things like m plus 0 is m. Yeah, but that only takes like 3 pages. Yeah, so the answer is it's a lot of work. The answer is it's a lot of work. If you... Oh... The universe strikes back. I smited Leo, and I myself got smited for... You can have constructive proofs that bash a huge formulas that aren't insightful. Whereas classical proof could relate it to concepts in theory. I don't know. Do you have a good example? What's a good example? 9 is loaded. What's 9? Do you agree that mathematics can be done using different kinds of reasoning, and depending on the situation, different kinds of reasoning are appropriate? Yeah, what a dumb question. Who would answer no? Like even a constructive, why would a constructivist answer no to that? Yeah, that is kind of a silly question. Yeah. You can compare with a lot of computational number theory proofs. Okay. Okay. Defining arithmetic operations is so hard, you need over 5,000 steps to define addition in metamath? What's metamath? Is that really, really, really bare bones? Okay, final question, and then we'll head out of here. Do you agree that all mathematical truths are true, but that some mathematical truths are more true than other mathematical? I kind of feel yes. I mean, the part of me that's just a formalist and it's just like, oh, it's formal systems. Like, obviously no. Obviously no. Obviously no. They're all as true. I don't know. Actually, I don't know. I don't know. Actually, I don't know on this one. It's a proof verifier that just uses symbol replacement. I see. And you've read through all of them. Jesus. Hey, you should stream. That would make for some fun content. I would definitely, while I'm working on my thesis, I'd put that on in the background. You'd like to avoid set theoretic arguments as much as possible. Oh. Yeah, I mean, okay, 100% Leo, 100% Leo. The actual process of doing the constructive proofs is tedious and annoying, 100%. But I would still say it's better. The fruits of your labor pay off to be able to hold the example in your hand. Anyways, I'm taking off now too. I don't know what's going on with the internet. But QED.